Good morning. Today we are going to look at 4.3, which is graphing using intercepts, and then also at 4.4, which is using slope. So first we're going to use a graph to find intercepts. It says the x-intercept of a graph is at point A right here, because this point is where it's crossing the x-axis. And then the y-intercept is right here at point B, because that's where it's crossing the y-axis. Now it says right here, the graph crosses the x-axis at some number, comma, 0. Because if we were to count over, let's say it's 1, 2, 3, that point would be 3, comma, 0, because we went x 3 to the right and left up and down on our y-axis, we went 0. If we were to look at this point y and we were to count 1, 2, 3, 4, x would be 0 because we did not go left and right on our x-axis, we went up 4. So if we notice on our y-axis, the x term is 0, and on our x-axis, the y term is 0. That'll come in handy in a little bit. But right now, they just want us to identify the x and the y-intercepts. So our x-intercept, this one is at 1, 2. They're crossing the x-axis at 2. And the y-intercept, it's crossing the y-axis at a -1. If we wanted to write these as a point, we could. This point would be 2, comma, 0, because x is 2 first. And this point, if we wrote this one down here, x, we did not go left and right, so 0. We went down 1. Again, on our x-intercept, y is 0, and on our y-intercept, x is 0. This one, our x-intercept is -1, 2, 3, -4 right there. And our y-intercept is up 1, 2, positive 2. If we wanted to write those as points, we could as well. Over here, it says draw the line that has the given intercepts. Well, this one's pretty simple. Our x-intercept is -3. These go by 4, so 3 would be right in the middle. And our y-intercept is 6. All we have to do is draw our line through those 2 points and add arrows to the ends. Same thing over here, x-intercept is -1, right there, and our y-intercept is 3. These go by 2, so 3 is right there. Please don't just draw a short little line right there. Make your line go all the way through from one side to the other. And put arrows on it to show it could go on. Next, we're going to find the x-intercept and the y-intercept of the graph of the equation. We're going to do this without actually graphing it. So I'm going to draw a little squiggle here. On this side, we're going to find the x-intercept. I'm going to shorten that word. And on this side, we're going to find the y-intercept. Now back here, oops, too far. When we found the x-intercept, y was really 0. And on our y-intercept, x was really 0. So we're going to use that information to help us find our x-intercept. So we just said for our x-intercept, y was 0. And for our y-intercept, x is 0. So we're going to plug 0 in to figure out what the other letter is. So it says 0.5x plus 3 times y, but y is we're going to plug in a 0, equals 9. Well, anything times 0 is 0, so we just have 0.5x equals 9. So to solve that, the opposite of multiplying would be divide by 0.5. And we get x equals, now 9 divided by 0.5, it's really doubling. How many times does 1/2 go into 9? It should go in 18 times. Or you can use your calculator. Alright, over here we have it 0.5 times x, and x is now a 0 on this one, plus 3y equals 9. Well, anything times 0 is 0, so we have 3y equals 9. And then last, divide by 3. So y would equal 3. We could graph those if we wanted to. Let's try a couple more. We're going to find our x-intercept and our y-intercept. Reminder, for our x-intercept, we're going to plug in y is 0. For our y-intercept, we're going to plug in x is 0. So first, y is 0. We have 0 equals -4x plus 10. Nothing cancels out because 0 is just 0 over here. So we're going to solve this. Get rid of your addition or subtraction first. I'm going to subtract 10. 0 minus 10 is negative 10, and we have negative 4x. And then last, the opposite of multiply is divide. So divide by negative 4. Two negatives make a positive. If you plug that in your calculator, you should get 2.5. This next one should be a little bit easier. X is 0, so it says y equals negative 4 times x, which is 0, and then plus 10. Well, anything times 0 is 0, so we just have y equals 10. We didn't even have to solve anything on that one. I would like for you to try these bottom two on your own, and then click play to see if you got them right. For our x-intercept, y is 0. For our y-intercept, x is 0. Let's plug it in. First, y is 0, so we have negative 3x plus 9 times 0 equals negative 18. Well, that makes 0, so we have negative 3x equals negative 18. And divide by negative 3. Two negatives multiply or divide to make a positive. 18 divided by 3 is 6. Same thing over here, but plugging in x is 0. Negative 3 times 0 plus 9y equals negative 18. So that makes 0. We have 9y equals negative 18. And then just divide by 9. 9 over 9 is just 1. And 18 divided by 9 is 2. So negative 2 is our answer. Now this last one looks really easy, finding our x-intercept and our y-intercept. But we need to be careful. First, when we plug in y is 0, we have x minus 0 equals negative 10. Well, this one, x minus nothing, is still just x. So we have x equals negative 10. That part wasn't too tough, but on the second part, when x is 0 here, we have 0 minus y equals negative 10. Well, 0 is still 0, but this minus goes with the y. So we really have a negative y equals negative 10. Well, that's really a negative 1y, so we need to divide. So we'd have y equals now a positive 10. Don't forget that negative goes with that letter. Now we have two where we have to find the intercepts, just like we did, and then plot the points to graph. So first I'm going to find my x-intercept and my y-intercept. My x-intercept, y would be 0. My y-intercept, x is 0. Remember, it's opposite of each other. So first, if y is 0, we have negative 2x plus 0 equals 6. Well, 0 is just 0, so we have negative 2x equals 6. So if we divide by negative 2, x equals a negative 3. And then our second one, x is 0, so negative 2 times 0 plus y equals 6. Same thing here, eliminates because that's just 0, and we have y equals 6. So let's plot the points. X-axis, we're at negative 3, right in the middle there. And then y-axis, we're at 6. So there is our line, and it says label the points. If we labeled this point, x would be 0 and y would be up 6. That's our point, xy. That's why on our y-axis, x is 0. That's why we've been plugging that in. And over here, this point right here, x is negative 3 and y is 0. We didn't go up and down. Let's find our x and our y-intercept on the next one. First, I'm going to find x and then y. So first, my y is 0. We have 0 equals, one thing I forgot about on this problem is I made a mistake when I wrote the equation. This needs to be a negative 0.5 or it's not going to fit on our graph. So we have 0 equals negative 0.5x plus 3. So if we solve this, get rid of your addition or subtraction first, subtract 3. We have negative 0.5x equals negative 3. And if we divide by negative 0.5, x should give us, well, a positive number. 0.5 goes into 3 6 times. So x would be 6, way over here on our x-axis. And then plugging in x is 0, we have y equals negative 0.5 times 0 plus 3. Well, that makes 0, so we just have y equals 3 right there. And draw our line through it. If we want, we can label the points x, y. X here would be 0, and we went up 3. And over here, x is 6, and we went up 0. Alright, next we have a problem. It's about event planning. It says, you are helping plan an awards banquet for your school, and you need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables seat 4 people, and large tables seat 6 people. This situation can be modeled by this equation. So they give us all of this information that we don't really need because they give us an equation that tells us what it means, which is nice, but here's our equation. X is the number of small tables, and y is the number of large tables. First, find the intercepts, meaning our x and our y intercepts. So I'm going to write x-intercept, y-intercept. First, y is going to be 0, then an x. So in our equation, y is 0 first, so it says 4x plus 6 times 0, which is y, equals 180. I'm going to write the second equation while we're at it. When x is 0, 4 times 0 plus 6y equals 180. So if we solve these, well, this part 0 is here, so we have 4x equals 180. And divide by 4. We get 45. On this one, x was 0 there, so we have 6y equals 180. We divide by 6. This one is easier to do in our heads. 18 divided by 6 is 3, with the 0 gives us 30. So we need to next graph the equation. Well, when we graph this, we need our x and our y intercepts graphed on here. Well, y has to go to 30 and x has to go to 45, so we can't go by 1s. If we go by 10s, that won't take up very much of the graph, so instead I'm going to go by 5s. And then on the y-axis, same thing. And then I'm going to plot my points. X-axis, I'm at 45 right there. My y-axis, I'm at 30. And this is one where it's really important that you use a straight edge to connect your points. Oopsies. If you don't, if you're a little off, it will affect your answers in the end, okay? So use a ruler, the edge of your paper, something like that. So we graphed our equation. It says, what do the intercepts mean? What does this point mean, and what does that point mean? Well, first, this one up here, if I label this, on my x-axis, I would be at 0. So this is 0 of whatever's on my x-axis. Well, my x-axis is small table, so I'm going to label this. These are the small, and then these are the large tables on this side. So right there are 0 small tables and 30 large tables. That means that everyone in this banquet could fit at all 30 large tables. We wouldn't need any small tables. At this point, though, this would be 45 small tables and 0 large tables. That means that we could also fit 45 small tables and fit everyone in the same way. Then it asks us to give 4 possibilities for the number of each size table you could rent. Well, here's one combination. Here's another combination. We need 2 more. And this is why I said it was important that you are careful when drawing your line, because we need to look for where 2 lines cross like that. Right at the middle would form nice numbers. So like this point right here, it's easy to read that there are, on my x-axis, 15 small tables, and on my y-axis, 20 large tables. That would fit the exact number of people that we need. This point over here would also be a nice point. There are 30 small tables, and over here, 10 large tables. Now there might be some other combinations in here, but I don't know exactly, is that 37 tables or 38 tables? I'm not quite sure. That's why we're going to use points where they cross nice and neat. And that's our answer. Second part of our lesson is on slope, finding slope and rate of change. So there are 4 types of slope. We always read slope like a book from left to right. So if we look at this slope, here's our slope man. From left to right, this is going up. We call this a positive slope. And then going down the other way, from left to right, we call this a negative slope. The mouth of our slope man flat across the bottom here, this would be a slope of 0. That's why there's a 0 right there. And lastly, our nose of our slope man going straight up and down, that is what we call undefined. And that's why there's a U there for undefined. So those are our 4 types of slope. There are multiple ways we can find slope, simply by counting from 2 points, rise over run. We could use our symbols, x's and y's, our 2 points, if we label them like this, xy, xy. We could plug those 2 points in to find our slope, or we could just count from our graph. First, let's identify what type of slope these are, whether it's positive, negative, 0, or undefined. Well, this one, if we put a little slope man on here, this person would be walking uphill, so this is a positive slope. This one is straight up and down. We couldn't walk across that. We would fall straight down. This is undefined. You can write UND if you'd like. This slope here, we'd be walking straight across with a slope of 0. We're not going up or down. And then last, this slope, we're going downhill. We call that a negative slope. I would like you to try and find these 4 on your own, and then check to see if they're right. So first, left to right, we read across, we are going downhill, so this is negative. This one, our slope man would be walking straight across a slope of 0. This one, we can't really walk across, that's what we call undefined. And then last, walking uphill, this one would be a positive slope. So next it says plot the points and draw a line through them. Without calculating, tell whether the slope is positive, negative, 0, or undefined. So first, to plot our points, we always label them in alphabetical order, x, y. Here's x, here's y. Be careful, they go by 2's. And if I'm going too quick, make sure you pause the video and write some things down. First, x is 0. We're not going left and right. We're just going negative 2, which is down 2. And then x is 9. Well, this goes to 10. 9 is in the middle. And negative 5 is down 2, 4, 5 right in the middle there. So there is our line going through it. Make sure it goes all the way through the graph from one side to the other. Now it says to tell me whether this is positive, negative, 0, or undefined. And if our slope man was walking across from left to right, we would be walking downhill, which is a negative slope. Our next one, this one goes by 4s, 4, 8, 12, 16. So if we plot these points, x and then y, x is 2, 2 to the right, and negative 10 would be down 10, right there. Then we have 12, 10, x is 12, 12 to the right. Positive 10 would be up 10. So putting our line through those 2 points, There we go. A little better. What kind of slope is this one? Well, our slope man walking from left to right would be walking uphill, so this is a positive slope. Next it says find the slope of the line that passes through the points. If it says find, that's what they mean as a fraction or as a number, not just positive or negative. So if you want to use the letter M to represent slope, you can. We will be learning that in a minute as well. So slope is always rise first, up and down, and then run left and right. It really doesn't matter which point you start from. I'm going to start on the left and count rise over run, knowing that positive numbers go up or to the right, and we would count negative if we're going down or to the left, because negative numbers would go to the left this way. So first, if I count rise, I'm going up 1, 2, so I went up 2, my slope is up 2. That's our rise number on the top, and then we're running 1, 2, 3. 2 over 3. If you started at the other point, you would have went -1, -2, and over to the left, -1, -2, -3. Two negatives would have made a positive, just like we have here. So let's try this one. From this point to this point, I like to start on the left. You can start at either point. I'm rising, or going down this time, -1, -2, and positive 1, 2, 3, 4 to the right. Well, 2 over 4 we can simplify by dividing by 2. That will give us the same as -1/2. Next, from here to here, our slope, we're going down -1, -2, -3, and over positive 1, 2, 3, 4, 5, 6. 3 over 6 is another one we can simplify by dividing by 3, and we get a -1 over 2, -1/2. This last one, there are no points on it. You need to find some points where they cross at nice numbers like they did here, whole numbers. This would be a good point. If we follow the line, this might be a good point, or that. There are 3 points. It does not matter which 2 you use, but you only need 2 points to find slope. So if I count my rise from here to here, I'm going up 1, and over 1, 2, 3. If you instead decided to choose this point and this point, you would rise 1, 2, and run 1, 2, 3, 4, 5, 6. And you could simplify that to 1/3. You really get the same slope. Alright, our next couple, find the slope of the line that passes through the points. This is using our equation now. y2 minus y1 over x2 minus x1. Well, we just need to label our points, x's and y's, alphabetical order. And this was my first point listed, so I give it 1s. This is my second point, so I give it 2s. All I have to do is plug it in now. So it says y2 minus y1. So y2 is -4 minus y1, which is 6. Then on the bottom, x2, which is 5, minus x1, which is 0. So -4 minus 6, they're all negative, so that's a -10. 5 minus nothing is still 5. We can simplify this even more. 10 divided by 5 would give us 2, or -2 for our slope. If you wanted to keep it as a fraction, it would be 2 over 1. Let's try this one. xy, xy. These are our first point, second point. And we're going to plug it in. y2 minus y1, so y2 is -2, minus y1, which is 2. And then x2, which is 5, minus x1, which is also 5. -2 and another -2, they're all negative, so that's -4. 5 minus 5 is 0. Now we need to think, is this okay or no? Well, the 0 is on the bottom, so no, this is not okay. It's not a slope of 0. This would give us a slope of 0. When it says no, when there's 0 on the bottom, we can't divide by 0. This is a slope that is really undefined. So that is our answer. I'd like for you to try these last two on your own. xy, xy. So plugging into our equation, y2 minus y1, so 4 minus 4. And then x2, which is negative 3, minus x1, which is 0. Well, 4 minus 4 is 0. Negative 3 minus nothing is still negative 3. This one is okay, so our answer is just 0. Our last here, xy, xy, this is my first point, second point, and plug it into our equation. y2 minus y1, looking at our equation here, we have 6 minus 3. On the bottom, we have x2 minus x1. This is where you need to be careful. x2 is 4 minus x1, which is also a negative 2. So those two negatives make a positive. 6 minus 3 is 3. 4 plus 2 is 6. And we can simplify that by dividing by 3. And we get 1/3. Now we're going to only do one of these problems because there's only a couple on your homework. And there aren't any of these on your test, but you do need to know how to do it. So they're giving us our slope right here. We need to figure out what one of the points is. We're going to follow this the same way. Our slope, which is m, is 5/6. And then we're going to label our points. xy first point, xy second point. And plug them in. y2, which is negative 1, minus y1, which is 4. And then x2 minus x1. On the bottom we have 6 minus x. Well, we can simplify this. This is really 5/6. And then negative 1 minus 4 is negative 5. We can't simplify 6 minus x. But this does look like something we've done before. We can cross multiply like we did in chapter 3. So if I multiply 6 times negative 5 on one side and set it equal to 5 times this whole piece, and this whole piece has adding or subtracting, so we need to keep that together, 6 minus x. Well, 6 times negative 5 is negative 30. If I distribute this, I can draw a box to multiply, or just multiply each term by 5. 5 times 6 is 30. 5 times negative x is negative 5x. So if I want x by itself, we need to get rid of this 30 first. I'm going to subtract 30. Negative 30 minus 30 is not 0. If I owe someone $30 and now I owe them another $30, now I owe them $60. And then the opposite of multiplying is divide by negative 5. Two negatives make a positive, and we should get a nice 12. So the number we were missing right there is just 12. The next problem, it says, the graph shows the cost in dollars to mail a letter that weighs 1 ounce during certain years. Determine the time interval, or which slope, during which the cost to mail a 1 ounce letter showed the greatest rate of change, or the greatest slope. So what you could do is just count rise over run for each one, or do xy, xy, y2 minus y1 over x2 minus x1 every single time. Or you can just look to see which one is going to be the greatest slope. This would be a pretty flat slope of 0. If something's going up like that, it would be the greater slope. So I can see by the graph, just looking down here, this one's going up a lot quicker than these flat ones are. So our greatest slope would be from the years 2001 to 2002. Now, the second part, determine the time interval during which the cost to mail a 1 ounce letter showed the least rate of change, or the least slope. This is one that you have to solve. You would need to find the slope between here and here, find the slope between here and here, and find the slope between here and here. You'd have to find 3 slopes and tell me which ones were the least, or the closest to 0. I'm not going to tell you the answer to that one. I would like you to try that one on your own. But this last one, we will talk about. It says, commuting to school. A student commutes from home to school by walking and by riding a bus. Describe the student's commute in words. So here we have time in the bottom as time goes on, and here are distance in miles, how far we've traveled. Well, if we're just looking at this first piece of our graph, quite a bit of time has gone by. If these are like 5 minutes, or even 1 minute at a time, that's a long time. And we haven't gone very far. We've only gotten to this first mark here. So I would say if it's taking you a long time but you're not going very far, I would say that you're probably just walking. Then, if time is going on but you're not going anywhere, we haven't moved from this spot, we haven't moved any further, I would say that you are probably just waiting. And then our last piece right here, not a lot of time has passed, but we've gone pretty far on our distance. So I would say that is when we are probably on the bus, because the bus can travel pretty quickly. So those are the types of words that I'm looking for when you look at problems like this. Your homework is right here, 4.3 and 4.4 worksheet. Make sure to show your work and ask if you have any questions.